Alright everyone, welcome back to the day 51 of our daily leetcode challenge, and today we have got find unique binary strings. So let's try to understand this question. In this question they have provided us with an array called nums, and it has got binary strings in it which are unique. All the binary strings present in nums are unique, and there is an interesting property in it that the number of binary strings that they have provided us in this nums is exactly equal. The length of each of the binary strings present in nums is exactly equal to the length of nums. So if the length of nums is 2, then it will have two binary strings, and the length of each will be 2. So if the length of nums is 3, it could have values like 1 1 1, 0 0 0, or 0 1 0. Now what are the actual possible values? The actual possible values is nothing but 2 raised to the power number of bits. Now these are the actual possible values. What I mean by that is, if the length of n is 3, if the length of nums is 3, this nums is actually a subset of all the possible binary strings possible, all the possible binary strings basically. So if the length of n is 3, meaning the values binary strings in nums will be formed of 3 bits. And what is the total number of binary strings that can be formed using 3 bits? It will be nothing but 2, and then 2 here, and then 2 here as well. If you multiply it all, you get 8. So 2 raised to the power 3, which is 8. And what are those 8 values? These are the 8 values. These are all the 8 possible values. This nums that they have provided is nothing but a subset of all the, consider this as a new list. The nums array that they have provided is nothing but a subset of this array. It's a subset of this array, and they have chosen they have chosen some values of it, and they want us to find what is the first binary string that is not present in this. So let's say that I chose these 3, then our nums will look something like this. I chose 0 1 0, 1 0 0, and 1 1 0. Now my nums array looks like this. Now what they want us to do is find the first binary string which did not appear in this subset that I have formed. So if we start looping from here, we'll find 0 0 0 is not one which is found. There are many values which are not present. 0 0 0 is not there, this value is not there, this value is also not present, this value is also not, but we need to just return the first value. Or you could say we can return any value, but it's better to return the first value so that the loop terminates earlier. So out of all these values that we have just arrowed, we could have returned any value. So this is how the question is built up. So in the case of where length of nums is 2, if the length of nums is 2, that would mean that it's going to have binary strings in this manner. Like these are the 4 possible values in the case of n is equal to 2. Out of these 4, they have provided any 2, any 3, or any 1 in the nums array. It could be 0 0 or 1 1, or it could be 0 1 1 0. This is how the question is made. Now what they want us to do is, out of all these 4 possible values, find the first binary string which is not present in this nums. Now it could be, in this case, in the first example, 0 0 is present, 0 1 is not present, this is a possible candidate. 1 0 is also not present, this is a possible candidate. In the second case 0 0 is not present and 1 1 is not present. These 2 are the possible candidates. We could return any one, but it's better to return the first one so that the loop terminates earlier. We'll be looping through all these values. Now also, if you notice, no matter what the value of n is, the minimum value and the maximum value will always be known to us, which will always be this 0 n times and this 1 n times. So if the value of n is 4, let's take that example now. If the value of n is 4, then the actual entire original array out of which the subset nums will be formed, which is our question array, will start from 0 0 0 0 and all the way till 1 1 1 1, and all the values in between. The nums that they will provide in the case where nums value is 4 will be any 4 values picked from this bigger array that will be formed. And what will be those values? They will be nothing but looking like something like this. You're going to have 16 values in total if you keep on doing that, because this will be 2 raised to power 4, so there will be 16 values. So out of these 16 values, they will choose any 4. Since the length of nums is 4, so they will choose any 4. We need to return the first binary string which is not present. So since we know that the minimum and the maximum value which are actually possible in this nums array, we know that we can loop between those two values and then find which one is not present. Rather than this nums, we'll convert this to a set. We'll convert this to a set so that the lookup becomes in constant space. So now we know that the maximum value will be 111, 4 times 1, or whatever is the value of n, and the minimum value will be 0 always. And the value will be ranging in these, exactly in this whole range. We'll loop through this entire range and find the first binary string which is not present in this set. We'll convert this nums array to a set so that the lookup becomes constant time. So this is how we're going to do. What we're going to do is, first we will declare our minimum and maximum values. The minimum value, if in the case of n, let's say n is 4 or n is 3, the minimum value num1 will be 0 3 times, this multiplied by 3, so this will become 0 0 0, and the maximum value, which will be num2, will be 1 3 times. So this will be our maximum values. Now all the binary values will be ranging in this. We need to find which is the first value in this range which is not present in set nums. We'll convert this nums from a list to a set. Once we do that, we just simply return the first binary string that we found. Now again, there will be this number of binary strings in this possible set can be large actually, because the value of n is going up till 16, and if the value of n is 5, the total number of binary strings that will be forming is 2 to the power 5. In the case of 2, we saw it was 2 square, which was 4, which is 0 0 0 1 1 0 and 1 1. In the smaller values it's fine, but when n value is going up till 16, the possible binary strings could be 2 raised to the power 16. So these are a lot of binary strings to handle with. So it's better to what we can do is convert these values to their respective decimal values. So this will be 0 and this will be 7. We'll be ranging between these decimal values now instead of binary. We'll range through these integer values and then convert them to their respective binary values, and then check this binary value in the set nums. If it's not present, we'll return this. So that's how we are going to solve this question. It will be a simple loop linear time solution, and let's try to code this up now. So as I said, we need two numbers which will be nothing but the maximum and minimum. So nums1 will be 0 multiplied by the length of nums, because this indicates a number of bits num1 will all the numbers are actually formed of, which is the length of the nums. If the length of nums is 2, it's formed of 2 bits. If the length of nums is 3, it's formed of 3 bits. This is a property which we noted earlier. And num2, which will be the maximum value, will be nothing but 1 multiplied by number of length of the nums that we have. Now we need to range between these two values, but not their binary form, their integer form. So to convert this to the integer form, we can do like this. Typecast it to integer of the base 2, so that now we have, instead of binary, these values are now integer. Now we need to loop, and also we need to convert this nums to set, so that we can do the lookup in constant time. Now we basically need to loop through all the integer values between this 0 and this maximum value, which is possible num2. We'll loop through all these values. These will be decimal initially. We'll convert it to binary. So let's do that. For each value, this is our range, num1, num2 plus 1, so that we also include num2 here. That's why we are doing a plus 1. Now we need to convert each of this value to binary. This can be done using this fstring property. Write val and put a b here. This will convert this value, which is initially a integer, since num1 and num2 are integer, to a binary. Now this binary will not have the actual zeros present in the left hand side. So what I mean by that is, if I convert 0, this is our decimal value, initially 0, but the binary value which will be getting will be just 0 like this. We need some preceding values here as well. So if you say I can represent 1 as this, or I could represent 1 as this as well in binary, or I could represent 1 as this as well. So the number of zeros on the left, on the right hand side, on the left hand side that we are putting here, this has to be exactly in accordance to the length of the nums list that we have. Since we saw that the length of nums is 3, if the length of nums is 3, the values that they are formed are of 3 bits. So 0 has to be in the form of this, not this. So the operation that we are doing at this line, is going to return us this for 0 instead of this. So to mitigate that, to kind of add those extra required zeros, what we can do is find the length of this binary, find the length of this binary that we have, that we just formed, find this length, and the extra zeros that will be required will be nothing but the length of the actual array nums minus this length. So the length of nums minus length of this binary string that we have. So this is going to have exact zeros that is required, but these are the extra zeros that we're going to add. So these are the extra zeros that we're going to add to this binary string that we are forming. So this is how this line right here is mitigating that extra zeros. We are adding that extra zeros accordingly by subtracting the length of this binary string and the number of zeros that it requires more. This is how we are finding it, subtracting the length of nums and then this value right here. So this is how we are getting the binary value. Now if this binary string that we have is not present, set 1, we can simply return binary, and that's pretty much it. This is the entire code. Let's try to run this up. So you can see it's passing all the test cases. So this is what I was saying. It could have been returned 111 as well, but it's going to always return the first value so that the loop terminates on time. If we go all the way up till the last value, it's going to require us extra time. So it's better to always return the first value which is not present in this nums. We converted this nums to a set so that the lookup becomes in constant time. So let's try to submit this. That's all the entire code for this one. So as you can see, it takes almost 0 milliseconds and beats almost all the solution. So this is how we use Python f string and convert them to integer, find the range, loop through all the ranges, convert them to binary back. This line right here is what we are doing is, as I discussed here, 0 could be represented, 1 could be represented like this, or 1 could be represented like 0 1 as well, 1 could be represented by 0 0 1 as well, and then 1 can also be represented as 0 0 0 1. Now which one we'll use? It all will depend on the length of nums. If the length of nums is 4, we need all the values in this form so that we are returning the correct value. It's going to expect this instead of returning just 1. It's going to expect this one. So add this extra zeros that we are adding here will be nothing but the length of this, the length of the entire nums, which is 4, minus the length of the actual binary string which we will be getting after this conversion. The conversion at line number, the conversion at line number 10, if you see this conversion right here, will only return us the actual zeros, not the mitigating zeros, not the zeros on the left. It won't add zeros on the left. To add those zeros on the left, we are doing that operation, 4 minus the binary string that we just formed, which was 1. So we did a 4 minus 1, which is 3. So we added 3 zeros. So this is how the solution is working. I hope you guys liked it, and this was it for today. I'll see you in the next one. Like and subscribe. Bye.